Good morning, students. Now we are learning theorem number 8 in the group theory, that is from unit 3, class number 3 for the second BSc students who are studying in who are in third semester for the academic year 2020-21. Now we are discussing with theorem number 8, that is if n is normal subgroup of G and H is subgroup of G, then we want to prove that Hn is subgroup of G, that is normal subgroup of G, given that n is normal subgroup of G and H is any subgroup of G. We are writing that what he have given in the theorem, and we want to prove that Hn is subgroup of G. By known theorem, a normal subgroup of a group G is commutative with every complex of G. By that theorem, here we can consider that H is a complex. That means Hn, n is a normal subgroup. H complex and normal subgroup Hn is equal to NH. That is, here H and N are only subgroups and NH is equal to Hn. That means Hn is a subgroup of G. Now we are going to theorem number 9. That is, if H is subgroup of G and N is normal subgroup of G, then prove that H intersection N is normal subgroup of G. Then the second one is N is normal subgroup of Hn. Okay. For that proof, we are taking that what is given that H is subgroup of group G and N is normal subgroup of G. We want to prove these two bits. That is, the first one is H intersection N is normal subgroup of H, not G. Are you understanding that? Yes. First of all, for that one, we know that H and N are two subgroups. Given that N is a normal subgroup means it is a subgroup and H is subgroup. H and N are two subgroups. That implies intersection of two subgroups is a subgroup. We know that in unit 1, in the unit 2, 2.1, intersection of two subgroups is a subgroup. That means H intersection is also H intersection N is also a subgroup of G. We know that H intersection N is contained in H and also in N also. Now I am using that H intersection N is contained in H. That means H is subgroup, H intersection N is subgroup, but H intersection N is contained in H. That means we can say that H intersection N is subgroup of H. Okay. But we want to prove that H intersection N is normal subgroup of H. So we want to prove the normal condition. For that I am taking that X belongs to big set. Here big set is H, not G. Are you understanding that? Because H intersection N is a subgroup of H. That's why I am taking the big set as H and the small set as H intersection N. Are you understanding that? For that, I am taking that X is in big set H and here small h belongs to H intersection N. Small h belongs to capital H intersection N means the small h belongs to capital H and small h belongs to capital N, both one. Correct? Here small x belongs to capital H, small h belongs to capital H and H is a subgroup. That means by closure law, XH belongs to H. We know that. And also X inverse is also in H. That means XH, X inverse is also in H. Okay, right. And the next one, we have X belongs to H and H is subset of G. That means all the elements in H is in G. Means X is in G. Okay, right. X belongs to G. Sorry, students. H belongs to N and N is normal subgroup. By the definition of normal subgroup, what happens? X, H, X inverse belongs to N. What is that? X, H, X inverse belongs to N. Okay, right? X, H, X inverse belongs to H. We got in the previously X, H, X inverse belongs to H. Now here we get X, H, X inverse belongs to N. Means X, H, X inverse belongs to both H intersection N. That means both means H intersection N. What we have taken? X belongs to H belongs to H intersection N. Here we have taken that H as a bigger set like G. Now X, H, X inverse belongs to H intersection N means this H intersection N is normal, but that is lies in H. That means H intersection N is normal subgroup of H. The first condition is over. What about the next condition? What do we have to prove in the next second week? Kindly follow the cursor, students. What is the second one? N is normal subgroup of Hn. What do we want to prove? N is normal subgroup of Hn. Okay, right? Now I am taking that small n belongs to capital N. We know that H is subgroup, means identity exists in H. That means E belongs to H, N belongs to N. Then what happens? En, E belongs to H, N belongs to N, means En belongs to Hn. Okay? En means N. En means N, because E into N, E is identity means N. N remains. N belongs to Hn. N belongs to Hn. That means where we have taken small n first, we have taken in a capital N, and that small n belongs to capital Hn. That means capital N is subset of Hn. N is contained in Hn. Okay, right? Now I am taking that the small x belongs to capital Hn and some a belongs to n. What is that? X is in Hn and a belongs to n. X belongs to Hn implies how the elements are be in Hn. The elements of Hn are like that as small h, small n. X belongs to Hn means X is also like that, small h into small n, where small h belongs to capital H and small n belongs to capital N. Now I am going with XA, X inverse. What is that? I am taking that XA, X inverse. X means Hn. I am replacing X with Hn in total. That is, X means Hn, A as it is, and X inverse means Hn whole inverse. What Hn whole inverse? We know that in groups unit 1, AB whole inverse is equal to B inverse, A inverse. By using that condition, we can write Hn whole inverse as N inverse, H inverse. Okay? Hn A is as it is. First three elements are as it is, and the last two elements inverse is Hn whole inverse can be written as N inverse, H inverse. Okay, right? I by associative law, I am applying brackets for the middle three elements. Okay, students? Now, if you understand that, then what happens to the total? What happens? All the element belongs to N. How it will be done? Because this element belongs to N. You know that? This element belongs to N. Because N is normal subgroup. H element in N, H inverse belongs to N, because N is again a normal subgroup. By the definition of normal subgroup, that is normality condition, that is in the second condition of the normal subgroup, you can treat it as single element which is in N, and H is in big set. H is in big set, that is G. H, NA inverse, H inverse belongs to N by the definition of normal subgroup. That means this XA, X inverse belongs to N. XA, X inverse belongs to N. That is, N is normal. What is the bigger set we have taken? X belongs to Hn. That means N is normal in NH. N is normal subgroup in, Hn. N is normal subgroup in Hn. Are you understanding that? Okay, right? The theorem proof of theorem number 10 is also over. Now we are going to the theorem number 10. What is that? If N and M are two normal subgroups of group G, then prove that the product NM is also normal subgroup of G. That means we can also get the question in the question paper like this also. That is, there is another model of question is there. That is, product of two normal subgroups of a group G is again a normal subgroup of G. That means if we take in two normal subgroups, then their product is also a normal subgroup for any group. Okay, right. For that proof, I am taking that N and M are two normal subgroups of G. We want to prove that NM, the product of N and M, NM is also a normal subgroup of G. Because N and M are two normal subgroups of G, that means the both sets are non-empty. N is non-empty, M is non-empty. Means that NM is also the product of two right cosets. So the product of the two normal subgroups is also non-empty. Two non-empty sets product is also non-empty. That means it may be NM or MN. The both are non-empty. By known theorem, we have a theorem that a normal subgroup of a commutative with every complex of G is commutes. What is that? A normal subgroup and a complex has a commutative property. That means here we can treat as N as a normal subgroup, M as a complex means NM is equal to Mn, abelian law. That is commutative law. Okay. Again, that by using that one, N and M are normal subgroups of G. Nm is equal to Mn means Nm is also said to be a subgroup of G by known theorem. That is theorem number, I think it is we have learned in the theorem number 8. H and N are normal subgroups of these, and NH is a or Hn is a subgroup. Similarly, by theorem, we can say that Nm is a subgroup of G. Now we want to prove that this Nm is normal subgroup. Here we prove that only subgroup. Now we want to prove that a normality condition. That is the second bit in the normal theorem. Second condition of the normal subgroup definition. What is the second condition? For that I am taking that X belongs to big set G, because Nm in G is the big set. That's why X belongs to big set G, and I am taking an element in Nm. What is that? Small nm is in capital Nm, where small n belongs to capital N and small m belongs to capital M. We have written here. Okay, right. What about X Nm X inverse? X Nm X inverse. I am taking E in between N and M, because E is the end, we can take like that. Okay, right. I am writing this E as X inverse X. All the remaining elements are same in this, and E replaces with X inverse X by inverse law. Is it right? Now I am interchanging the brackets. That is, by associative law, you can observe that I am interchanging the brackets for the three elements N X inverse X, and the remaining M X inverse, last two elements are outside the bracket. Now I am interchanging the brackets to the first three elements and the remaining three elements. Then what happens? X n X inverse, because X belongs to G, N belongs to N, N is normal, means X n X inverse belongs to N. X n X inverse belongs to N. X n X inverse belongs to N. Okay, right. Then what about Xm X inverse? X belongs to G, M belongs to M, and M is normal. M is also normal. That means X M X inverse belongs to M. M is normal definition. X M X inverse belongs to M. That means this product belongs to Nm. What is this product? X Nm X inverse belongs to Nm. What we have taken? X is in big set G, Nm is in capital Nm. X Nm X inverse belongs to Nm, means Nm is normal. Nm is normal. We have already Nm is subgroup. Kindly follow the cursor. Nm is subgroup. Here we get N is normality condition. That means therefore Nm is called normal subgroup of G. N and M are two normal subgroups separately we have taken, and the product Nm, the product of two normal subgroups Nm, is also a normal subgroup of G, we have proven here. Okay, students. Now we are closing this class. This is class number 3. So students, I am requesting you once again that all of you want to write down the notes regularly, and after that kindly ask me the questions, or that means any doubts. You can ask me the doubts in our WhatsApp group. Kindly follow that. I will explain elaborately in that one also, because in this video I have some restrictions to close the video in between in the restricted time. That's why I am unable to explain elaborately. If you have any doubts in this normal groups, the normal subgroups, class 3, then you can contact me in the WhatsApp group. I will clearly explain here to each and everyone. That means to one-on-one, by clearing their doubts, and you can understand very easily. Students, hope you understand that, and I hope you follow my guidelines. Thank you.